All right, good afternoon, everyone. Thank you for being here today. My name is Rob Shores, and I'm thrilled to have the opportunity to talk to you about a topic that's critical to the aluminum extrusion industry, fibers. Today, we'll explore the properties of high-performance fibers, their role in the extrusion process, and the risks posed by counterfeit materials. These materials are the unsung heroes of the industry, ensuring that aluminum profiles are handled safely and efficiently. By the end of this session, you'll have a deeper understanding of how to identify genuine fibers, avoid the dangers of counterfeits, and make informed decisions to protect your operations. So let's dive in. Before we get into the details, let me introduce Albury again. We are a vertically integrated manufacturer specializing in technical needle punch felts for industrial use. For decades, we've been the trusted supplier to the aluminum extrusion industry with our Defender heat felts. What does vertically integrated mean? It means we control every step of the process, from sourcing raw fibers to manufacturing the final product. This ensures that we maintain the highest quality standards at every stage. Our expertise lies in creating solutions that are tailored to the unique needs of our clients. Whether it's developing heat-resistant felts for high-temperature zones or designing cost-effective materials for final stage cooling, we're committed to innovation and excellence. At Albury, we like to say we go from fiber to fabric to fit. This means we don't just provide materials, we provide solutions that fit your specific requirements. All right, to give you a better understanding of what we do, let's take a quick look at these videos. Here you can see our raw fibers are processed and prepared for needle punching. This involves several steps, including carding, layering, and bonding. Each step is carefully controlled to ensure the final product meets the highest standards of quality and performance. These processes are the foundation of the high-performance fabrics we'll be discussing today. That's what makes Albury a leader in the industry. Now let's move on to the second video, which highlights the needle looms process. All right, this video showcases our needle looms in action. Needle punching is a fascinating process where fibers are mechanically entangled to create a strong, durable fabric. It's a critical step in manufacturing technical felts that can withstand the demands of aluminum extrusion. What's interesting about this process is how customizable it is. Depending on the application, we can adjust the density, thickness, and composition of the fabric to meet specific requirements. For example, a high-temperature zone might require a denser fabric with PVO fibers, while a cooling zone might use a lighter fabric with polyester. You are looking at the only seamless tube loom in North America. All right, here's a quick overview of what we'll cover today. An introduction to PVO, Kevlar, Nomex, and polyester, a comparison of these properties and applications, the role of fibers in the aluminum extrusion process, how to identify counterfeit fibers, the problems and risks associated with counterfeit fabrics. Each of these topics are interconnected, and together they paint a complete picture of the challenges and opportunities in the industry. Let's start with the first topic, introducing the key fibers. All right, let's begin with PVO, or polybenzooxazole. This is a high-performance synthetic fiber that often referred to as the superhero of technical fabrics. Why? Because it offers a combination of properties that are unmatched by any other material. PVO is known for its exceptional heat resistance, strength, and durability. It's ideal for high-temperature applications like aluminum extrusion, where materials are exposed to extreme conditions. Here are some of the key properties of PVO. Unmatched heat resistance. PVO can withstand temperatures up to 1200 degrees Fahrenheit, 650 degrees Celsius. This makes it a go-to material for the hottest zones in the extrusion process. It has exceptional strength. PVO is 10 times stronger than steel by weight. This means it can handle the mechanical stresses of aluminum extrusion without breaking down. Thermal stability. PVO maintains its structural integrity under extreme conditions, ensuring consistent performance. To put this in perspective, imagine a conveyor belt in an extrusion plant. It's exposed to high temperature, heavy loads, and constant movement. PVO ensures that the belt performs reliably, protecting the aluminum profiles and minimizing downtime. PVO is truly a game changer in the world of high-performance fabrics, as it sets the standard for what's possible in the industry. Let's break it down a little further. PBO's heat resistance is due to its unique molecular structure, which allows it to maintain its properties even at very high temperatures. This is critical in aluminum extrusion, where materials are exposed to intense heat as the profile is exiting the die. Its strength and durability also makes it ideal for applications where mechanical stress is concerned. For example, PBO is often used in roller covers and pads, where it provides a protective barrier between the aluminum profiles and the machinery. PBO is a truly game changer in the world of high-performance fabrics, and it sets the standard for what's possible in the industry. Next, let's talk about para-aramid, commonly known as Kevlar. Kevlar is widely used in the aluminum extrusion industry for its exceptional strength, heat resistance, and durability. Some of its key properties include high heat resistance. Kevlar can withstand temperatures up to 975 degrees Fahrenheit, 523 Celsius, making it suitable for high temperature zones. Exceptional durability. Kevlar is highly resistant to abrasion and wear, which is critical in demanding environments. Surface protection. Kevlar protects aluminum profiles from scratches and damage, ensuring a high quality finish. Kevlar's high heat resistance is slightly lower than PBO, but still an excellent choice for high temperature applications. Its durability also makes it a reliable option for conveyor belts and rollers, where it can withstand constant movements and friction. Now let's take a look at meta-aramid, or Nomex. This fiber is essential in industries that require thermal stability and high temperature protection. It's widely used in aluminum extrusion for handling and protecting profiles during cooling and finishing. Nomex's heat resistance, it withstands temperatures up to 750 degrees Fahrenheit, 398 degrees Celsius. Durability, superior abrasion resistance, making it highly durable. And surface protection, safeguards aluminum profiles from damage during handling. Nomex is particularly well suited for mid-temperature zones, where it provides a balance of heat resistance and cost effectiveness. It's often used in belts and pads that handle aluminum profiles during the cooling process. Finally, we have polyester. While it's not as heat resistant as the other fibers, it plays a crucial role in the final stages of aluminum extrusion, where precision and cost efficiency are key. Polyester is known for its affordability, durability, and versatility, making it a popular choice for lightweight, reliable materials. Polyester's temperature resistance is lower, up to 482 degrees Fahrenheit, 250 Celsius, but it's still sufficient for cooling zones and other low temperature applications. Its cost effectiveness also makes it an attractive option for operations looking to optimize their budget without compromising our quality. Now that we've introduced the key fibers, let's compare them side by side. This chart highlights the properties, including heat resistance, durability, surface protection, and cost effectiveness. For example, PBO is unmatched in heat resistance, while polyester is the most cost-effective option. Understanding these differences is crucial for selecting the right material for your specific needs. For instance, if you're working on a high-temperature zone, PBO or Kevlar would be the best choice, but for the final stage cooling, polyester often offers a more economical solution. Let's take a closer look at each property and how it impacts performance in the aluminum extrusion process. The material properties chart provides a detailed comparison of various materials used in the aluminum extrusion process, specifically PBO, Kevlar, Nomex, and polyester. Each material exhibits unique characteristics that make it suitable for specific stages of the process. By breaking down these properties, we can better understand their strengths, weaknesses, and how to choose the most effective material for your operation. PBO, or polybenzoxazole, I like saying that. PBO fibers are renowned for their exceptional heat resistance, withstanding temperatures up to 1200 degrees Fahrenheit, 650 C. This makes them ideal for use in high temperature areas, such as initial extrusion exit zones, where the aluminum is still extremely hot. PBO also offers a superior wear resistance and durability under heavy loads, ensuring longevity and extreme conditions. However, due to its advanced properties, PBO is often the most expensive material, making it best suited for high demand applications. So Kevlar, while slightly less heat resistant than PBO, Kevlar can handle continuous temperatures up to 900 degrees Fahrenheit, 482 Celsius. It provides excellent strength, abrasion resistance, and dimensional stability, which makes it a reliable choice for mid-range temperature zones in the extrusion process. Kevlar balances performance and cost effectiveness, offering a durable option without the premium price tag of PVO. Nomex fibers are optimized for moderate heat-resistant applications, functioning effectively in temperatures up to 500 degrees Fahrenheit, 260 degrees Celsius. While not as robust as PVO or Kevlar, Nomex remains a popular choice for its affordability and lower weight. It's particularly useful in zones where heat and wear demands are not as extreme, filling a critical need in less intensive stages of the process. And polyester. Polyester is 480 degrees Fahrenheit, 250 Celsius. It is the most economical, designed for use in low temperature areas. It excels in final stage cooling on handling zones where cost efficiency and light materials are more critical than heat or abrasion resistance. Its low cost and adequate performance makes polyester the preferred choice for applications with minimal thermal or mechanical stress. By understanding these properties of these materials in relation to the requirements of each extrusion stage, manufacturers can precisely match material performance to operational demands. When selecting materials, consider factors such as maximum operating temperature, wear resistance, and overall cost to optimize your production efficiency and maintain consistent product quality. Fibers play a critical role in the aluminum extrusion process. They act as protective layers, ensuring that aluminum profiles maintain their shape and quality during extrusion. This graphic provides an overview of the aluminum extrusion process, highlighting where fibers come into play. Fibers are strategically utilized at various points in the aluminum extrusion process, with each type of fiber specifically designed to handle the unique temperature and pressure requirements of each stage. At the mouth of the press, where temperatures are at their peak, PVO fibers are commonly used in roller covers, belts, and pads. PVO exceptional heat resistance ensures optimal performance under these extreme conditions. Moving further along in the process, as the aluminum begins to cool, Kevlar fibers become more prominent in applications such as roller covers, belts, pads, and tape. Kevlar offers a robust balance of heat resistance and flexibility, making it ideal for this cooling stage. As the extrusion continues to cool, we see Nomex fibers come into play, often found in belts, pads, and spacer bar sleeves. Nomex is well suited for moderate heat conditions, maintaining excellent durability as the temperature decreases. Finally, near the end of the extrusion process, where temperatures drop even further, polyester becomes the preferred material. Polyester is utilized in roller covers, pads, sleeves, and tape, providing an economical and effective solution for the final stages of the process. This strategic use of fibers ensures that each stage of the aluminum extrusion process is optimized for performance, offering protection, reliability, and efficiency from start to finish. But here's a critical question. What if the fibers protecting your aluminum extrusion process were secretly sabotaging it? Using the wrong fiber, or worse, a counterfeit fiber, can have serious consequences. For example, a fiber that can't withstand high temperatures might break down during the extrusion process, leading to contamination of the aluminum profiles. Similarly, a fiber with poor abrasion resistance might cause scratches or dents, compromising the quality of the final product. Each fiber we've discussed, PVO, Kevlar, Nomex, and polyester, has a specific role to play in the extrusion process. PVO and Kevlar are ideal for high temperature zones where heat resistance and durability are critical. Nomex is well suited for mid-temperature zones, providing a balance of performance and cost effectiveness. Polyester, on the other hand, is perfect for cooling zones where precision and affordability are key. By understanding the role of each fiber, you can optimize your extrusion process and ensure the highest quality output. Counterfeit fibers. Counterfeit fibers are growing a problem in the industry. There are substandard materials that mimic genuine, heat-resistant fibers but fail to meet the required specifications. How can you identify these fibers? Conduct a visual and physical inspection. Genuine fibers like PBO have a golden brown color, smooth texture, cool to the touch. It actually feels cool in your hands, while Kevlar is yellowish, lightweight, and UV radiation alters its color. Meta-aramid is creamy white, soft, but durable, and polyester is smooth, shiny, and flexible. And here are some common testing methods to ensure the authenticity of your materials, like heat resistance and tensile strength tests, and of course, always check for certifications and supplier documentation. And now let's take a look to discuss this TGA analysis graph, which provides critical insights into the thermal stability of roller covers. This chart is particularly important because it highlights the risks of using counterfeit or substandard materials in high temperature applications. Here's the context. A customer approached us with concerns about the performance of roller covers they had purchased from another supplier. These covers were marketed as being 100% Kevlar or para-aramid, but their performance in high temperature zones raised red flags. We conducted a thermogravimetric analysis to evaluate their thermal stability, and the results were eye-opening. So if you look, the x-axis of the graph represents temperature, ranging from 0 to 112 degrees Fahrenheit, while the y-axis shows weight loss as a percentage. Each curve represents a different roller cover material, including both soft, which is non-resin treated, and resin treated options. So Albury, the one marked Albury's para-aramid soft pads, demonstrated the highest thermal stability, retaining nearly 90% of the weight, even at 1076 degrees Fahrenheit. This makes them ideal for high temperature zones where durability and performance are critical. Then the lines marked Albury Kevlar and para-aramids, both the soft and the resin treated, also show excellent performance with minimal weight loss up to 1076 degrees Fahrenheit and gradual degradation thereafter. These materials are well suited for mid-temperature zones, providing a reliable balance of heat resistance and durability. In stark contrast, the line marked the others, para-aramid soft and resin treated. The two gray dotted lines degraded rapidly, starting at 212 degrees Fahrenheit for the soft and 752 degrees Fahrenheit for the resin treated, losing almost all their weight by 1076 degrees Fahrenheit. This steep decline is a clear indicator of poor thermal stability. The green highlighted area labeled minimal weight loss degradation emphasizes the superior performance of Albury materials, while the blue highlighted area showed very fast decomposition degradation, underscores the risk of using substandard alternatives. This analysis revealed that the roller covers in question, which were labeled as 100% Kevlar or para-aramid, actually contained filler fibers to cut costs. These filler fibers significantly compromise the thermal stability of the materials, leading to rapid degradation at high temperatures. This example underscores the importance of verifying the authenticity of materials. Using counterfeit or substandard fibers can lead to equipment failure, contamination of aluminum profiles, and costly downtime. By choosing high-performance fibers like para-aramid and Kevlar, you can ensure the longevity, efficiency, and safety of your operation. Let's put your knowledge to the test. Can you identify the fibers? During a recent visit to a customer, we encountered an interesting situation that raised some red flags. The roller covers in this facility were labeled as PBO Kevlar, but upon closer inspection, something didn't add up. Here's what we observed. The color of the roll covers were inconsistent with what we know about genuine PBO and Kevlar fibers. PBO typically has a golden brown hue, while the Kevlar is known for its yellowish tone. These covers, however, look noticeably different. The texture also seemed off. Genuine PBO and Kevlar have smooth, durable surfaces designed to withstand high temps and mechanical stress. These covers lack the expected quality and finish. Can you identify the fiber? This discrepancy immediately caught our attention because the appearance of the roller covers didn't align with the properties of authentic PBO Kevlar materials. Why does this matter? Using counterfeit or mislabeled fibers can lead to serious issues, including reduced performance. Counterfeit materials may not withstand the high temps and mechanical stress of the aluminum extrusion process. Contamination risk. Substandard fibers can break down, leaving debris on aluminum profiles. and even safety hazards. Inferior materials may fall under extreme conditions, potentially causing equipment damage or accidents. This example underscores the importance of being able to identify genuine fibers. By understanding the key characteristics of PVO and Kevlar, such as their color, texture, and performance properties, you can spot inconsistencies and avoid the risks associated with counterfeit materials. On the next slide, we'll dive deeper into the problems and risks of counterfeit fabrics, exploring how these issues can impact your operation and what you can do to protect your processes. Counterfeit fabrics pose significant risks to the aluminum extrusion process, and their impact can be far-reaching, affecting not just the quality of your products, but also the safety and efficiency of your operation. Let's take a closer look at these risks. What are fake fibers? Counterfeit or substandard materials that mimic genuine, heat-resistant fibers but fail to meet required specifications. First, let's talk about contamination and surface defects. Counterfeit fabrics often fail to meet the required specifications for heat resistance, durability, and abrasion resistance. This can lead to contamination of aluminum profiles. Substandard fibers may break down under high temperatures, leaving debris or residue in the aluminum. This contamination can compromise the integrity of the profiles and lead to costly reworks. Surface defects, poor quality fabrics can cause scratches, dents, and other imperfections on the aluminum profiles. These defects not only affect the appearance of the final product, but can also lead to functional issues, especially in industries where precision is critical. Reduced efficiency. Counterfeit fabrics often wear out faster, leading to frequent replacements and interruptions in the production process. This results in increased downtime and lower overall productivity. Next, let's consider the safety risks. Counterfeit fabrics are not designed to withstand the extreme conditions of the aluminum extrusion process. This can result in equipment failure. Inferior materials can break down or fail under high temperatures, causing damage to machinery and potentially halting production. Possibility of accidents. The failure of counterfeit fabrics can create hazardous conditions for workers, increasing the risk of injuries. For example, a roller cover that disintegrates under the stress could lead to flying debris or other dangerous situations. The financial implications of counterfeit fabrics are also significant. Using substandard materials can result in costly rework and repairs. Contaminated or damaged aluminum profiles often need to be scrapped or reworked, leading to additional expenses. Loss of clients. Delivering products with defects or delays caused by counterfeit materials can damage your reputation and result in lost business opportunities. Increased operational costs, frequent replacements, downtime, and repairs all add up, making counterfeit fabrics a far more expensive choice in the long run. So how can you avoid these risks? Here are some of the key red flags to watch out for when sourcing materials. Unusually low prices. If a deal seems too good to be true, it's probably a counterfeit material, are often sold at significantly lower prices to attract buyers. Lack of certifications. Always verify that the supplier provides proper certifications and documentation to prove the authenticity of their products. Inconsistent textures and colors. Genuine fibers like PVO and Kevlar have distinct characteristics, such as their color and texture. Any inconsistencies could indicate counterfeit materials. It's also important to work with trusted suppliers who have a proven track record in the industry. Counterfeit fabrics may seem like a cost-saving option at first, but the risks they pose far outweigh any short-term savings. By staying vigilant and informed, you can protect your operation, ensuring the quality of your products, and maintain the trust of your clients. In conclusion, our goal is to design a handling system that provides maximum longevity, cost-effectiveness, and protection for aluminum extrusions. By understanding the properties of genuine fibers and staying vigilant against counterfeits, we can achieve this goal and ensure the success of our operations. Thank you for your attention. I'll be happy to answer any questions you have.